Good morning, students. Today we are going to start the fourth lecture of the topic of vectors in the subject of Pure Mathematics 3. So concentrate yourself. Our first topic for today is position vectors. Position vector of a point A relative to the origin is given by OA. So this is the definition of the position vector. So if you look at this triangle, so if we want to find AB, so look now, if we want to find AB, so A is the starting point. So if this AB is given in the is going in this direction, we have to move in the opposite direction. So listen again, whatever the direction of AB, we have to move in the opposite direction, and then we have to meet the next part of the vector. So we will start from here and we will move in the opposite direction and we will reach here in the end. So look now, AB is in direction, so we will start from A and we will move in the second direction. That will be equal to AO. And because we have to reach at this, so AO plus OB. So this will be the method. So again listen, whatever the direction of the vector will be, so we have to start from the first position and move in the opposite direction. So that is OA. And then we have to reach at the final position. So if AB is in direction, we will move in this direction, AO plus OB. So look now, this OB will remain as it is, and AO is the opposite of is the negative of OA. So look now, AO is negative of OA because direction is opposite. So we will write minus OA in the place of AO. So this is the head to tail rule. So that is here for triangle law of the vectors. For triangle OAB gives AB is equal to AO plus OB, and this OB will remain as it is, and AO will be opposite of the OA. So this is the addition rule, that is also called head to tail rule, or this is also called triangle law of the vectors. Here is another question from the topic of position vectors. So the statement of the question is, consider the cuboid OABCDEFG. So this is the cuboid. The unit vector I, J and K are along OA, OC and OG. So here is I, OA, then J, OC, then K, OG. Also OC is 10 centimeter. So look now, this is 10 centimeter and OA 15 centimeter. This is 15 and OG 5. Okay, all three measurements are given on the figure, and X and Y are the midpoints of DE and GD. So these are the midpoints of DE and GD. Okay, find OX in terms of I, J and K. So whenever you are going to find this kind of question, this kind of figure, actually these are vectors, so we will apply head to tail rule. The thing is in first part OX. So this is the thing which we are going to find out. So you have to careful. We will adopt head to tail rule and we will follow the path in which values will be given. So OX is the requirement. So from here to here we have to go. So that will be equal to OA plus AD plus DX. And if you can see at this path, all values are given. This is given, and this is also given. Because this is given, that will be parallel to this one. So the path we are going to follow is OA plus AD plus DX. So another thing to remember is we have to start from here. So we have start from here and end at here. So look now, we have end at this thing. So OX is equal to OA plus AD plus DX. So because these are vectors, so we have to be very careful about the directions now. So OX is equal to OA is equal to, so look now, direction is along the vector of us. So OA is equal to 15 plus AD. So this is the same direction. So this is given 5 plus dx. But okay, dx is also in the same direction, but x is the midpoint. So if this is 10 total, so then half will be 5. Okay, but at the same time, you have to be careful about the unit vectors because OA is I, so 15I plus 5K plus 5J. And finally, you will write it in alphabetical order. So that will be 15I plus 5J plus 5K. So this is the vector OX. So likewise, we will follow the same rule in second part, that is OY. So if you look at OY, so here is O and here is Y. So you will follow the path OG plus GY. Okay. Now you will put the values. So OG is 5K plus this is half of the full path. So if this total is 15, this will be 7.5 I. So the vector is 7.5 I plus 5K. So this is OY. And finally, the requirement is XOY angle. So here is another technique that will be applied. So look now, cos XOY. So look now, this is very important technique. So the alphabet at which the cap is there, you have to grip that alphabet. From there you will move to left side and then to right side. So OX vector and then OY vector. And in the denominator you have to take the magnitude of these two vectors. So listen again. The alphabet at which the cap is there, you have to move from there to left and then to right. So OX dot OY, and then you have to take the magnitude of these vectors in the denominator. So now you will put the values into it. So OX vector, here is OX vector, that is 15, 5, 5. So look now, OX is 15, 5, 5. So this is OX dot OY. Here is OY, that is 7.5. J is not there, that will be 0. So 7.5, 0 and 5. And in the denominator, you have to take the magnitude of these two vectors. So here is OX. So 15 square plus 5 square plus 5 square square root into 7.5 square plus 0 square plus 5 square whole square root. So now you will solve it on the calculator. Respective elements will be multiplied. So look now, 15 into 7.5, that is 112.5, plus 5 zeros are 0 and 5 fives are 25. And in the denominator you have to take the magnitude of this one. So 15 square is 225, plus 25 plus 25, square root into 7.5 square, that is 56.25, and plus 5 square 25, square root. So in the next step, okay, come here. Here is space, so we will solve it here. Okay, 112.5 plus 25, that is equal to 137.5. In the denominator we have to add them and then take the square root. So that will be make 2 to 5 and 50, 275. So square root 275, that is 16.58. And in the next bracket is 56.25. So 56.25 plus 25, square root 9.01. So in next step, 137.5 will remain as it is. In denominator you will multiply these two values, multiplied by 16.58, that is 149.45. Okay, further 137.5 divided by 149.45, this is 0.92. And here is cos this thing is coming, but requirement is x or y is the requirement. So x or y will be equal to cos inverse 0.92. So cos inverse 0.92 is equal to 23.07. So this is the answer. Here is another very important question. The position vectors of A, B and C are given by OA is this, OB this, and OC equal to this. Okay, find the position vector of D such that ABCD is a parallelogram. Okay, look now, if ABCD is a parallelogram, so definitely it will be like of this figure, this shape, A, B, C, D. And other important rule to remember in naming it is you have to follow a clockwise order or an anti-clockwise order. So I have follow anti-clockwise order. So A, B, C, D. So listen now. If a student name it like AB, so this is anti-clockwise, and then CD, the question may be wrong because in this order is clockwise. So half of the order is anti-clock and half of the order is clockwise. So this may be wrong. So look now, you have to follow the same order A, B, C, D. So this is very important point. Okay, look now, in first part it is given that the position vector of D such that ABCD is a parallelogram. Okay, from here you can see in the first part AD will be equal to BC, because in our parallelogram, opposite sides are equal and parallel. So AD will be equal to BC. So from here you can see AD can be written like OD minus OA, and on the right side you can see it can be written as OC minus OB. So after this you will apply the values because OA, OB and OC values are given. So from here you can see OD will be equal to OC minus OB, and this will go to the right side, it will become positive, so plus OA. So now putting values here, OC is P minus 914. So P minus 914, this minus sign is here, and OB 5 minus 1 2, 5 minus 1 and 2, this plus sign is there, and OA 2 3 minus 4, so 2 3 minus 4. Okay, you will solve it now. So P minus 5, P minus 5 plus 2, so P minus 3, minus 9 plus 1 minus 8 plus 3 minus 5, 14 minus 2 12, minus 4 8. So this is the answer of first part. The second part is the value of P if A, B and C are collinear. So another very important part. So concentrate yourself. Here is second part. For collinear, all the points should be on the same straight line. So it means A, B, C will lie on this same line. Okay, in terms of vectors, so AB, so because we are required P and P is involved in OC vector, so we have to involve C. So look now, OA, because they are parallel vectors also, so OA will be K times of BC. You may write AC also because we have to involve C. So OA is equal to KBC, K times of BC, or you may write AC in place of BC also because that will give you the same answer. So here is AB. So AB is K times of the BC because all the points are vectors are parallel. So here we will put the values. So AB will be equal to OB minus OA, and K times of here will be OC minus OB. So now we will put values into it. OB is 5 minus 1 2 minus OA 2 3 minus 4. On the right hand side, K times of OC, P minus 9 14 minus OB. Here is OB 5 minus 1 2. Okay, solve it further. So 5 minus 2 will be 3. Minus 1 minus 3 will be minus 4. and 2 minus 4 will be 2 plus 4 will be 6. On the right hand side you have k as it is, and p minus 5, minus 9 plus 1 will be minus 8, and 14 minus 2 will be 12. Okay, from here you can see that 6 or minus 4, you may take either of two values. So minus 4 is equal to k times of minus 8. From here you can see 4 over 8 will be equal to k. It means k is equal to 1 by 2. Okay, now taking the first value, so 3 is equal to k times of p minus 5. So putting values here, 3 equal to k is 1 by 2 into p minus 5 is still there. So p minus 5 will be equal to 6. And from here minus 5 will go to the right side and p will be equal to 11. So second part done. And now the last part, the position vector of q. If AQ ratio QB is equal to 3 ratio 4. Okay, look now, this is third part. So AQ QB ratio QB is equal to 3 ratio 4. Okay, from here we can write it as AQ over QB is equal to 3 over 4. And from here 4AQ will be equal to 3 times of QB. Okay, from here this 4 will remain as it is. Okay, we are going to erase some space. We are going to create some space for us. So look now, this 4 will remain as it is. And AQ will be written like OQ minus OA is equal to 3 times of QB. So that will be equal to OB minus OQ. Okay, from here open the bracket, 4 OQ minus 4 OA equal to 3 times of OB minus 3 times of OQ. So minus 3 OQ will come here, it will make 7 OQ now. And this 4 OA will go to the right side, so 3 OB plus 4 OA. Putting values into it, so 3 is as it is, and OB vector is 5 minus 1, 2. This plus 4 is still there, and OA is 2, 3 minus 4. So solving it now, we will multiply the constant value inside and plus at the same time. So 3 5s are 15 plus 8. 3 minus 1s are minus 3 plus 12. 3 2s are 6 minus 16. So the last step is, okay, second last step is 23 plus 9 and minus 10. Okay, in the last step 7 will go to the right side, so OQ will be equal to 1 by 7 times of 23, 9 minus 10. So this is the position vector of Q. Here is another question that is important. Given that OP is equal to I plus 2j plus 4k and OQ is equal to 4I minus 2j plus 4k. Find the vector of length 25 in the direction of PQ. So be very careful. First, you have to find the unit vector of PQ and then the new vector whose length is 25 in the direction of this one will be find out. So look now. First, we are going to find the unit vector. So first part is unit vector of PQ is going to be find out. So it means PQ's unit vector will be equal to PQ vector over PQ magnitude. So actually these are the things which are required. So first we will find the vector PQ. So PQ vector will be equal to OQ minus OP, and OQ is 4 minus 2, 4. 4 minus 2, 4. Okay, minus OP is 1, 2, 4. Now solving it, 4 minus 1 will be 3, minus 2 will be minus 4, and 4 minus 4 will be 0. So this is PQ vector that will be placed in numerator, and in the denominator we want the magnitude of this vector. So PQ magnitude will be equal to 3 square plus minus 4 square plus 0 square. So that will be equal to 16 plus 9, 25, and square root will be 5. And because we have taken the square root, so that's why plus minus value will be there. Okay, and magnitude is in positive number, so that will be 5. Okay, now putting values into this one, into this formula. So PQ unit vector will be equal to 1 by 5 into this vector 3 minus 4, 0. Okay, now we want a vector whose length is 25 in the direction of PQ. So let B vector is this. So that will be equal to B is equal to B magnitude into PQ unit vector. So putting values here. So here is 25 magnitude into PQ unit vector, and that is 1 by 5 into 3 minus 4, 0. So 5 5s are 25. So 5 times of this one. So 5 is going to be multiplied inside. So that will make 15 minus 20, 0. So this is the vector which is having 25 magnitude and in the direction of the PQ. Okay, in second part it is given that OR is equal to this one, where X is the constant, and PR is equal to 2 times of PQ. Find the possible values of X. Okay, look now. In second part, this is the condition PR is equal to 2 times of PQ. So this is the condition given. From here we will start. OR will be equal to, so OR is given, okay. OR minus OP will be equal to 2 times of the OQ minus OP. Okay, solving it. 2OQ minus 2OP. From here, minus 2OP will, okay, we want OQ. So 2OQ. Okay, just simple it. This minus OP will go to the right side. So OR will be equal to 2OQ and plus, so minus OP will be left. Okay, at this stage, we will apply the values. So OR is given, there is no J, so it means 3, 0 and X. 3, 0 and X vector is this one. On the right hand side, 2 times of OQ. Here is OQ, 4 minus 2, 4. Minus OP, that is 1, 2, 4. Okay, solving it. 8 minus 1 will be 7. Minus 4 minus 2 will be minus 6. And 8 minus 4 will be 4. And on the left hand side is this one. And from here, x is equal to 4 is the answer.